2.2.3 Personal Fall Arrest System Inspection. The personal fall arrest system should be inspected monthly by a competent person. Remember, we talked about before that a qualified person has knowledge and knows how to mitigate problems. But a competent person also has the authority to take corrective actions. So that's the difference. And has the authority. Okay. 2.2.4 Lanyards. Lanyards consist of some primary material of construction, rope, webbing, aircraft cable, with a connecting device attached to the ends. Lanyards used for fall arrest systems are either shock absorbing or self-retracting. Non-shock absorbing lanyards, such as the ones shown in Figure 16, are used for positioning and fall restraint, not fall arrest. So if they don't have a shock absorber, you can use them for positioning and fall restraint, but not fall arrest. Lanyards used for positioning are not considered part of the fall arrest system. They are fall restraints and will be attached to D-rings on the harness other than the back D-ring. Since fall restraint is all about preventing a fall from happening, lanyards used for positioning should not allow a fall or movement greater than 2 feet. 2 such lanyards are usually required to permit movement from one place to another. Here we can see a shock absorbing lanyard. The lanyards are 6 feet long, but they have extra material inside them. And as you fall, the webbing breaks the threads and it elongates from 6 feet to 9 feet, but it does it in a controlled fall, a controlled way, so that you don't just fall and get to the end of the string like a yo-yo and get snatched back up. You slow down. It actually absorbs that shock. That's why they call it shock absorbing. It will fall in such a way that you slow down and come to a rest at the end of the lanyard. The one on the bottom, this is the retractable lanyard. So you can walk around, or you can climb, you can do what you need to do. But if you do fall, it'll only allow you to go 2 feet, and then it locks like a seatbelt. These are the positioning. They're non-shock absorbing lanyards. They don't have a shock absorber. You don't see anywhere where the webbing is a zigzag pattern or accordioned. So they do not absorb shock. They're stagnant. They're only for positioning. The D-ring used on the personal fall arrest system for fall arrest may only be connected to one live connection at a time. This can be challenging when trying to move from one point to another, especially horizontally. The user must be able to reach back and disconnect a lanyard while maintaining one lanyard connected at all times. A Y-configured lanyard can be used for this purpose. So here's a Y-configured lanyard. It has the one position with a fall arrest soft stop that connects to the D-ring, and then it has 2 lanyards that can be connected and disconnected in order to allow movement. What this drawing is illustrating is that if you're 6 feet tall and you've attached retractable lanyard 2 feet above your head, it'll only allow you to fall 2 additional feet. So there's the 6-foot lanyard plus the 2 feet of the retractable lanyard. That's 8 feet, and then you're 6 feet tall, and you end up being 3 feet off the ground. Whereas over here, if you're using a stagnant lanyard, you're going to fall the full 6 feet, plus you're 6 feet tall, and you end up, you have to be tied off 18.5 feet from the ground. The anchorage point has to be 18.5 feet above the ground in order to protect you. This one only has to be 15.5 feet. Okay, so lifelines. Vertical lifelines must have a minimum breaking strength of 5,000 pounds. Anything dealing with fall is 5,000 pounds. Just remember that. This is a lifeline. You can actually move up and down on this lifeline. The roofers use them a lot because you can move up and down an angled roof, but you still have fall protection if you do slip. Beam grab. All right, here's a horizontal lifeline. I know this is for demonstration purposes only. He's not 6 feet above this other roof, but they're just showing you that if he's working on the edge of a roof, he's within 6 feet of the edge of the roof, then he needs to have fall protection. And here he's wearing his fall protection, and it's anchored to a lifeline, and the lifeline is supported at multiple places, and each one of those anchor points is good for 5,000 pounds. So he can walk along this line. When he gets to the anchor point, he can go over and move his D-ring, or his anchor point. He can move it to the other side of the support and continue walking, the whole time being protected from falling off the side of the building. All right. Guardrails, 2.2.6. Guardrails are a common type of fall protection. They protect workers by providing a barrier between the worker and the ground or lower work area. They may be of wood, pipe, steel, or wire rope. Must be able to support 200 pounds of force applied in any direction on the top rail and 150 pounds for the mid rail. So these are not protecting you by stopping a fall. So they don't have to be good for 5,000 pounds. They have to be able to take a 200-pound force horizontally. So tangentially to the support. The support is vertical. It has to be able to withstand a 200-pound force on the top of the rail, moving horizontally, perpendicular to the stanchion. And then they go on and talk about the guardrail must be 42 inches plus or minus 3 inches, and the mid rail has to be in the middle of that. So here are guardrails. These are pipe or tube guardrails. Safety nets. Again, as they're discussing these topics, they're getting further and further away from the danger. What I mean by that is you want to have guardrails to keep you from getting to a point where you can fall. If you're going to get to a point where you could fall, you need to wear a safety harness. This is for an area where someone was working and either they weren't wearing a safety harness or they weren't obligated to wear a safety harness. I don't know why that, but a lot of times when you're working on bridges, they'll do this. They'll put a safety net below the bridge. So anyone who accidentally falls over the side of the bridge will end up in the net. Safety nets are used for fall protection on bridges and similar projects. They must be installed not more than 30 feet beneath the work area. There must be enough clearance under the safety net to prevent a worker who falls into it from hitting the surface below it. There must also be no obstruction between the work area and the net. So they don't want it to be like a circus net where you fall into it and you get sprung back up and you hit the bottom of the bridge. Like, that's not good. So they're saying you have to have enough clearance below the bridge so that if you do fall into it, you're not going to bounce back up like a Super Bowl or something. End up hitting the bottom of the bridge. Depending on the actual vertical distance between the net and the work area, the net must extend 8 to 13 feet beyond the edge of the work area. Mesh openings in the net must be limited to 36 square inches and 6 inches from the sides. So 36 square inches is a 6 by 6 netting. They say that that's small enough that your foot won't go through it, hopefully a 6-inch opening. If you ever were in a situation where there's a net below you, I know it's hard not being circus trapeze artists to incorporate this into our daily living. If you are falling, try to lie flat. You increase your surface area by lying flat and spread eagle. You spread your legs, you spread your arms. That way, the net has a much better chance of stopping your fall, and you won't get hurt. If you hit that net like an arrow, like a dart, if your feet are together and pointed, you could rip through the net. You could rip through that netting and keep going. I hate to say it, but that has happened. Try to lie flat. Increase your surface area. All right. 2.3.0, ladders and stairs. Overloading means exceeding the maximum intended load for a ladder. So all ladders come with a maximum intended load depending on, I know there's a table 2, there you go. I think it's the color of the ladder, but here you've got a type 3 ladder, good for 200 pounds, light duty. A type 2 is 225 pounds, a type 1 is 250 pounds. The type 1A is good for 300 pounds, extra heavy duty professional use. I believe that they're yellow. I could be wrong about that. I'll have to look that up, but I think they're yellow. Know that a type 1A ladder is good for 300 pounds, and then the type 1 double A is good for 375. But the type 1A ladder is good for 300 pounds. Just remember that. You might see that again. All right. So here are the different types of ladders. If you are studying the electrical course, we will never use aluminum ladders because we're electricians and aluminum conducts electricity. We don't use aluminum ladders. You're not allowed to use wooden ladders on the job anymore either because they hide defects. There could be a split in the grain of the wood. They've gotten away from it. Most often, everybody uses the fiberglass ladders nowadays. So you're going to want a fiberglass step ladder or an extension ladder or a straight ladder. The difference between the straight ladder and the extension ladder is, if you guessed it, the straight ladder doesn't collapse in the middle. The extension ladder is 2 pieces of ladder hooked together. You can extend the length of the ladder. Here's a platform ladder. It's got a platform at the top. Oh, this one right here, the fiberglass platform ladder. And here's a rolling warehouse ladder. Okay. It says a caution, use ladders only for their intended purposes. Ladders are not interchangeable. Incorrect use of a ladder can result in injury or damage. You're never supposed to take a step ladder and collapse it and lean it up against the wall. I've seen a lot of guys do that on the job site. Confession, I've done it myself. You're not supposed to do that. It's against OSHA regulations. That's using that ladder in a way that it was not intended to be used. So you're supposed to get a straight ladder and lean it up against the wall. But a lot of guys just use that step ladder. So I'm telling you, that's not allowed. And drop testing safety nets. Let's see what they have to say about this drop testing safety. Safety nets should be drop tested at the job site after the initial installation, whenever relocated after a repair, and at least every 6 months if left in one place. The drops test consists of a 400-pound bag of sand, 29 to 31 inches in diameter, that is dropped into the net from at least 42 inches above the highest working surface at which workers are exposed to fall hazards. If the net is still intact after the bag of sand is dropped, it passed the test. So they take a 400-pound bag, 29 to 31 inches in diameter, and they drop it from like 42 inches above the highest working surface. So if you took a running start and you leapt up into the air, you'd be hard pressed to get higher than 42 inches. I guess some of the professional basketball players can do it. I can't. Anyway, you jump up in the air and then fall down into the net. They're doing it with a 400-pound bag of sand. They say if the netting doesn't give way, then it passed the test. Straight ladders. Let me see if I can just give you the meat and potatoes here. I'm gonna just, the rails are the sides of the ladder, the rungs are the straight pieces in between. So here's a 2-rail ladder, and then the rungs are the rungs between. Usually you can count the rungs of a ladder, and you can tell how tall that ladder is. If it has 8 rungs, it's 8 feet. If it has 10 rungs, it's 10 feet. Count the rungs, and that's usually how tall the ladder is. And they go on to say that metal ladders conduct electricity and should never be used around electrical equipment. Any portable metal ladder must have a danger do not use around electrical installations stenciled on the rails in 2-inch letters. I don't think they use aluminum ladders on the job sites anymore. I don't think they use aluminum or wood. At least that's what I'm hearing. They only use fiberglass. You have to check to make sure that the cleats are good. Got cleats and feet. You want to check those, make sure that they're in good working order. Check the rails, make sure that they are sun bleached and cracking. You want to make sure that the rungs are nice and secured, and where everything is bolted together, the bolts are still intact. If you lean a ladder up against a wall, which you're allowed to do that, a straight ladder, you can lean it up, even an extension ladder, you can lean it up against the wall. You have to have 3 feet, that's 3 full rungs, above the landing on which you're going to step off of the ladder, okay? So if this is 16 feet, the top of the ladder has to be at least 19 feet, it has to be 3 feet higher than the landing. That gives you something to hold on to as you're stepping off onto the roof or to the second floor, or whatever it is that you're stepping onto, a platform, what have you. Here they're telling you the rungs are 12 inches apart, and the working length of the ladder is how high the ladder is off the ground. If this is 16 feet to the landing above, that's the working length of the ladder, 16 feet. The bottom, the foot of the ladder has to be 1/4 that distance away from the wall. If it's a working length of 16 feet, the bottom, the feet of the ladder need to be 4 feet away from the wall. If it's 20 feet working length, the feet have to be 5 feet away from the wall. It's 1/4 the working length of the ladder. Here's my highlight. The distance between the foot of a ladder and the base of the structure it's leaning against must be 1/4 the distance between the ground and the point where the ladder touches the structure. That's called the working length. Stated another way, there should be a ratio of 4:1 between the distances. And then they go on to give you an example. I just gave you those examples. You can tie off the ladder by staking it at the bottom and tying it off. They also have these fireman hooks, I think they call them, that go over the top of the precipice, and you can latch your ladder onto that. Okay. Moving up or down a ladder. This is going to take some practice. This is something that is in your performance profile for this section. You're going to have to set up an extension ladder and ascend and descend the ladder wearing a safety harness. You have to have 3 points of contact at any one time. So that's 2 feet in one hand, 1 foot in 2 hands. So you move a hand, you move a foot. You move a hand, you move a foot. But anytime you stop moving, you should have 4 points of contact. While you're moving, you should only be moving one of those 4 points of contact at a time, so that you're always making 3-point contact with that ladder. I know we've seen the action hero movies where they run up a ladder and they've got 2 points of contact, the left foot and the right hand, or the right foot and the left hand. No, you're not allowed to do that. We're not action heroes. We're going to go slow. We're going to go one step at a time. We're only going to move 1 point of contact at a time. To carry a tool while you're on a ladder, use a hand line. So you're not allowed to carry anything up a ladder except a length of rope. And you roll it into a circle and you put it on your shoulder, and then you climb that ladder still using 3 points of contact. When you get to the top, you can hang on to one end or tie it off and throw the other end down to your helper. They can tie on the toolbox or tool bag or the bucket or whatever it is that you're hauling up. They tie it off and then you can haul it up with the rope. You don't carry material up a ladder in your hands, because that means that you don't have 3 points of contact. If you're holding a drill motor in your hand, there are going to be moments that you only have 2 points of contact. So you have to use a bucket. Extension ladders, they have to be overlapped at least 3 feet. Most of them are manufactured in such a way that you can't go less than that. So there's 3 feet. Same deal with the feet of the ladder have to be 1/4 the working length of the ladder away from the building or whatever you're leaning up against. You have to check the feet, the cleats, the rungs, the rails, make sure everything is good before you use it. Here's a warning. Let me read the warning. It says, extension ladders have built-in extension stop mechanism. Do not remove this mechanism. If the mechanism is removed, it could cause the ladder to collapse under a load. Okay. So there it is. Step ladders. Yeah. I went over to my neighbor's the other day. I asked to borrow his step ladder. He said, yeah. He says, I can let you borrow my step ladder. He says, I never knew my real ladder. It's a step ladder. You'll get it later. Here are the parts of the step ladder. Same thing. They've got rails and rungs. This ladder is made in a certain way where it has rungs on both sides of the ladder. I don't know if I like that or I don't like it. You can only have one person using a ladder at a time. And it used to bother me when I was working on a ladder and I was up on the second or third step and I was working in a drop ceiling. All of a sudden I'd feel my ladder shaking, look down, and the foreman is climbing up the back side of the ladder because he wants to talk to me. No, don't climb up my ladder while I'm on it. Because if you knock the ladder over, guess what? I'm going to fall. You're going to take me down with you. Call me. I'll come down. We'll have our conversation. Then I'll go back up and go back to work. Sometimes guys, they don't think that good. And he's thinking, well, I'll save him a little effort. He doesn't have to come down. I'll just climb up the back of his ladder. Don't do me any favors. Call me. Let me get off the ladder. Then we'll have a discussion. All right. Never stand on the top step or top of a step ladder. We have to talk about vocabulary. Some people call this the top step of the ladder. It's not a step. This is not a step. This is the top of the ladder. This is the top step, and you're not allowed to step on the top step of the ladder. I know that sounds ridiculous. Why did they put it there if you're not allowed to step on it? You're only allowed to step on the second step, which is this one right here. You can't stand on the first step and you can't stand on the top of the step ladder. You have to stand no further than the second step of the ladder. The reason they put that first step there is to give the ladder rigidity. It makes it more rigid so it doesn't wobble around, and it gives you something for your shins to lean up against to stable you when you're standing on the second step, or the second rung, I should say. Okay. So the top of the ladder is not a step, so they want you to stand on the second step, which is the third one down, if that makes sense. I say it that way because there have been miscommunications in the past where the book said, don't stand on the top 2 steps, calling the top of the ladder a step. But you're not supposed to stand on the top of the ladder or the first step of the ladder. You can stand on the second step or below of a step ladder. All right. Now that we've gotten that cleared up, never stand on the top step or the top of a step ladder. Putting your weight this high will make the ladder unstable. The top of the ladder is made to support the hinges, not to be used as a step. Although the rear braces may look like rungs, they're not designed to support your weight. Never use the braces for climbing or climb the back of a step ladder. However, there are specially designed 2-person ladders available with steps on both sides. I regret that they called it a 2-person ladder. It's not. It's a special designed ladder that has rungs on both sides, so that when you set it up and you're on one side and you want to be on the other side, you can get off the ladder, walk around to the other side, and climb the back of the ladder. Because both the back and the front are made exactly the same. They're both, it's like a push me, pull you. They both are able to be climbed, but not by 2 people. No, no, no. Warning, never stand on a step with your knees higher than the top of a step ladder. You need to be able to hold on to the ladder with your hand. Keep your body centered between the side rails. All right. 2.3.4. Inspecting ladders. Always inspect a ladder before you use it. Check the rails and rungs for cracks or other damage. Also check for loose rungs. If you find any damage, do not use the ladder. Check the entire ladder for loose nails, screws, brackets, or other hardware. Okay. OSHA requires a regular inspection of all ladders and an inspection just before each use. Let's see, let's move on. Stairways. I'm sorry that this is taking so long. Safety is the most important thing we'll ever discuss in these classes. So that's why this module is extra long, and it's why it's taking so long for me to get through it, because it's important. Safety is the most important thing we'll ever talk about. I know that safety is the first thing that you should learn in class. And it's something that should be stressed at every step of the way. When you start learning about conduit bending, the first thing you should learn is safety. When you learn about threading conduit, the first thing you learn should be safety. When you learn about pushing a fish tape in a conduit, you should learn about safety. Every module should have safety as the first thing you learn before you go on to learn the rest of the module. It's that important. Okay. Let me go here. Stairways. Stairways having 4 or more risers or rising more than 30 inches, whichever is less, must be equipped with at least 1 handrail and 1 stair rail along each unprotected side. Winding and spiral stairways must be equipped with a handrail offset sufficiently to prevent walking on those portions of the stairways where the tread width is less than 6 inches. Okay, and stair railings must not be less than 36 inches from the upper surface of the stair railing system to the surface of the tread. All right. Let's see. Stairways must have adequate lighting. This can sometimes be a problem because permanent lighting is usually installed after stairway construction is completed. Whenever possible, avoid using stairways to transport materials between floors. Whenever you see a stairway on a job site, you're not allowed to use it until, and I don't think, if it's wood, they're carpenters, if it might be iron workers, whoever's making that stairway, they have to say, we're done. We completed this stairway, and they'll tell the general contractor that they're done erecting that stairway, and then the stairway will be open to the public. If you see a stairway and it's incomplete, don't use it. If you haven't been told specifically that that stairway is able to be used, don't use it because you could get hurt. It may not be welded. It may not have had the concrete poured on the landings. For whatever reason, if they have not released that stairway, don't use it. It's not available for public use yet. All right. 2.4.0, scaffolds. Scaffolds provide safe elevated work platforms for people and materials. Designed and built to comply with high safety standards, but normal wear and tear or incidentally putting too much weight on them can weaken them and make them unsafe. Here's a caution. Only a competent person, that's someone who has the authority to take corrective actions, has the authority to supervise setting up, moving, and taking down scaffolds. Only a competent person can approve the use of scaffolds on the job site after inspecting the scaffold. Types of scaffolds. Sometimes things are said. I'm not going to say I agree with 100% of everything in these books. It says there are two basic types of scaffolds: self-supporting scaffolds and suspended scaffolds. So if you're asked that on a question, know that the answer is two. There are two basic types of scaffolds: self-supporting scaffolds and suspended scaffolds. The rules for safety use apply to both of them. Self-supporting scaffolds can be manufactured units or can be assembled at the job site. There are also rolling scaffolds. So I guess they are including rolling scaffolds in the category of self-supported scaffolds. Suspended scaffolds are ones that are suspended by rope or chain or cable overhead, like you see window washers using them in the big skyscrapers in New York City. They use a suspended scaffold to come down the side of the building and clean all the windows. So you've seen them in movies. Here is a manufactured scaffold. You have top rail and mid rail, and they've got a toe board. They've got a ladder that's already built into the side of the scaffold, and that's fine. You're allowed to use this if it's manufactured this way. You're allowed to climb that. Otherwise, you are not allowed to climb the cross bracing on a scaffold. You have to use a ladder. Even if you have to get a step ladder or an extension ladder and use it to get to the top of the scaffold, you have to use a ladder. Okay. Warning, never unlock the wheel brakes of a rolling scaffold while anyone is on it. People on a moving scaffold can lose their balance and fall. So here's built-up scaffold. It's I think they called it a pipe and plank. So here's the piping, you put it together, you have these brackets, these vices, and you clamp them into place, and you have side bracing, and it keeps it from collapsing horizontal runners and guardrails, vertical posts. There you go. You have to have a screw jack at the bottom so you can level it, and you have to have a footer, a foot plate. There you go. And there's a suspended scaffold. You can see the ropes that are holding it. With a suspended scaffold, the workers have to have their safety line anchored to a point not holding the scaffold. So the scaffold has its own anchor points. The workers have to have their own separate anchor point. You can't anchor to the same. If the anchor point gives way and the scaffold falls, and the worker is also tied off to that same anchor point, then he's going to fall. So you have to protect the workers by having them anchor to a point other than the anchor point for the suspended scaffold, if that makes sense. All right, here are some more examples of suspended scaffolds. Those are worker cages. Okay, inspecting scaffold. Any scaffold that's assembled on the job site must be tagged to indicate whether the scaffold meets OSHA standards and is safe to use. 3 colors of tags are used: green, yellow, red. What do you think? Green, you can use it. Yellow is caution. Red, don't use it. Okay. So, complete. The scaffold is complete in every way, and you can work on it, and you don't have to wear a safety harness while you're working on the scaffold. It's complete. If there's anything that's not complete, it gets a yellow tag, and you have to wear a fall arrest system while working on that scaffold. And if it's red, it means they're either assembling it or disassembling it, and you don't have any business being on that scaffold. So, to use a yellow tagged scaffold, you must wear a safety harness attached to a lanyard. Okay, you see that? Green tag means the scaffold meets all OSHA standards and is safe to use. A yellow tag means the scaffold does not meet all OSHA standards. An example is a scaffold on which a railing cannot be installed because of equipment interference. So you have to wear a fall arrest system. A red tag means the scaffold is being put up or taken down. Never use a red tagged scaffold. All right. I'm going to move on here. Using scaffolds. Warning. Keep scaffolds a minimum of 3 feet from power lines. Man, I say 30 feet. Stay away from power lines. You don't want to get anywhere near them. They say a minimum of 3 feet. And they say unless it's high voltage, then you're supposed to stay 15 feet. Well, stay 15 feet or 20 feet. The further away you are, the safer you are. Don't get anywhere near a high line. A barrier with yellow and purple marking indicates radiation. Remember that purple was magenta. Positioning lanyards are used only as fall restraint devices and may not be used as fall arrest devices. True. Positioning a straight ladder against a wall, how far from the wall should the base of the ladder be? 1/4 the distance from the ground to the point where the ladder touches the wall. It's the working length of the ladder, the working distance, 1/4. If a scaffold has a yellow tag on it, it means a safety harness must be worn when using it.